When it comes to lighting, there's a lot of lighting terms you need to know. I'm going to break them into two categories. One of the categories is quantity of light, so amount of light. The other category is quality of light. This video is about the quantity of light. So there's a few different terms that deal with the quantity or amount of light. So quantity is how much light is available. The first one is called the lumen. People call it lumen. Lumen is actually a unit for luminous flux, but nobody says how much luminous flux does something have. They say, how many lumens is it? So lumens are the actual amount of light of the bulb. So it's we can measure with a lumen. We can measure the lumens, and that is a measurement of how much light or the brightness of that bulb. Watts is not a measure of the brightness of a bulb. So a lumen has a specific definition, and it has to do with candelas. Candelas are basically the amount of a bit of a candle light that comes through a specific little pinhole in a closed box, and that's how the SI unit, International System of Units, defines it. But what you need to know is that the symbol lumen, LM, is the SI unit for luminous flux, which is the amount of light or the brightness that comes off a light. Now, you could have a lot of lumens, very bright, but it doesn't take a lot of watts. Or you could have not a lot of lumens and take a lot of watts to make that. So lumens has nothing to do with the watts or the power of the light. So we used to say, oh, let's take out a 60-watt bulb and put in a 100-watt bulb. If we were used to be just talking incandescent, then typically a 100-watt bulb would have more lumens. It would be more bright. However, watts is the power and lumens is the brightness. When you're talking retrofits, you have a lot of different technologies of bulbs, and you could get a lot of lumens for not a lot of watts lately. Efficacy is the next measure of quantity of light. Efficacy is lumens per watts. So you might say, well, efficacy is efficiency, but it's not. In order to measure efficiency, you would have to normalize. So you would have to make a scale and divide by divide by the largest number of the group that you are measuring. So you would have to normalize efficacy to get efficiency. But efficacy is a ratio. That ratio exists for every lighting source. The lighting source has a certain amount of lumens or brightness, and it takes a certain number of watts, electrical power in watts. So that lumens or brightness divided by the number of watts it takes is defined as the efficacy. Efficacy and efficiency are often mixed up. A lot of people call lumens per watts the efficiency, but it is efficacy in terms of lighting. And if you really like the subject, you can dig deeper in this. And there's a handbook that I put up here, the Illuminating Engineering Society, the Lighting Handbook. This is sort of the gold standard of all lighting knowledge in the entire world. I brought this in to our library at Conestoga so that you can download a version for yourself and really explore the topic of lighting. Now, back to quantity of light. Lux. Lux is an SI unit. Lux is an SI unit for illuminance. Illuminance is not lumens. Lumens is brightness. Illuminance is a measure of the amount of lumens that made it to the task surface you are illuminating. It is an SI measure, and it is calculated as the luminous flux, or the lumens, per meter squared of a flat surface you are trying to light. So lux describes how intensely those lumens are spread over that area. So I put an example here of 1,000 lumens. That's the brightness, 1,000 lumens. If that 1,000 lumens concentrates over a desk and that's your task area of 1 meter squared, then it is illuminating with 1,000 lux. The SI unit of lux would be lumens over 1 meter squared to get the SI unit of lux. If the same 1,000 lumen light bulb is spread over a large desk of 10 meters squared because you hung it higher or you used a different type of sort of dome around it, then that will only calculate to 100 lux. That will look dimmer to the person who is operating that task. You might have heard of the term foot candle. Foot candle is lumens per foot squared at the task surface. So lux, or illuminance measured in lux, is actually what you might have heard as a foot candle of light. So I'm not going to have you calculate anything in foot candles, but a foot candle is 10 lux, and lux is the SI unit that we need to use. Now, illumination measured in lux, and remember, lux is a lumen per meter squared. Lumen is a brightness. So there are a lot of tables for illumination, and you get more practical if you're talking about illumination. Lumens, yes, it's a kind of a science quantity of how bright something is, but illumination, you've taken the science of that light bulb and you have applied it to a physical situation where there is a meter squared of work to do that you care about. Now, what's an example of something where you want some good lighting? I would say at a hospital, like getting an operation. Part of the reason why hospitals, when you do your benchmarking, hospitals are huge energy consumers is because you don't want to spare the amount of lumens per meter squared that is shining down on you on an operating table. There's 1,000 lumens per meter squared shining down on you on an operation table. So that's a measure that is called illumination, measured in lux. However, let's say you go to Toronto and you're sitting at the subway station waiting for the train. It's a public area, but it's kind of dingy, isn't it? That's because the number of lumens per meter squared, or the lux, the illumination, in a subway station waiting for a train is not a lot. At school, we want you to be pretty productive. So we give you more than what you see in a subway station. No offense, but that's classed as easy office work. And so we give you 250. If you do a little bit more detailed work, so for example, drawing, or I would say detailed drawing work these days would be sort of, your math that you're sitting at doing at your desk, you get as much or more than an operation room. I can't think of any examples where you're doing very special visual tasks that should be this much greater than an operation theater, but maybe you can think of that. So I hope you find that that's really interesting. The illumination measured in lux is lumens per meter squared, the amount of brightness hitting the task. However, it's no sense giving a lot of illuminance or a high quantity of light per meter squared. If you haven't cared about the quality. So later on, we're going to talk about the quality of the light. You don't want to make this operation theater have flicker and glare and contrast and things like that. So I'm just going to talk about lifetime here as well. The lifetime of bulbs does vary considerably, and incandescent bulbs can have very short lifetimes where high pressure sodium, which we'll talk about in next week's lecture, could last up to 25,000 hours. So the lifetime obviously factors into your equations when you're calculating your energy balance.